Hello, welcome to Ekidel, where future engineers come to learn structural design. My name is Justice Nwaka. I am your instructor. Today, I'll be showing you how to analyze and design this 8-story building right here in Prota Structure. And looking at this right now, this is an office building which is having 8 floors, as you can see it right here. This is 1, 2, 3, 4, 5, 6, 7, and 8. So this is having 8 floors, and also at this other end, it also has a semi-detached 4-story building right here. Okay, so right now I'll be showing you how to design this structure right here in Prota Structure software. But before we begin, there are some things you have to consider before you now begin to design any high-story building of this nature. The first thing you have to consider is to apply your wind load, because as you can see that this structure right now is more than 10 meters high. As you can see, this is 25 meters high, and we all know that wind load is being applied on a structure that is up to 10 meters high. So once your building is up to 10 meters high, you are required to apply a wind load. Okay, but before we start applying the wind load, and also in this in my coming video, I also perform a foundation design for this structure. And since this is an 8-story building, we will be using a pipe foundation to design for the foundation of this structure. And in that pipe foundation, I will explain to you in details all you need to know about pipe foundation, which also we will also go ahead and also detail the pipe foundation drawings. Now, but before we start all this, I will say for you not to miss all these videos, I will say you should just click on the subscribe button so that you don't miss my coming video when I will be performing all this. Okay, so right now let's begin to apply the wind load, because before you can start to design an 8-story building or any building more than 10 meters high, the first thing you do is to apply a wind load. So to begin that wind load right now, we will now have to apply the wind load to this structure. Okay, so let's begin right now for that. Okay, so to apply our wind load to this structure right now, the first thing we'll do right now is to just go right here. You can see here loading. Is to go right here called loading tab, and then click on the loading tab right here. And then we will now go for this. You can see it here. You can see these two. You have load case and then wind load. The first thing you do is to apply load case and combinations. So you click on this place right now, load case. Now, I have already applied this load case, so I'll just delete all the load case which I have right now to show you afresh. So when you click on this, once you click on this load case, the next thing you see right now you do is to now click on this tab, loading generator. So once you click on that right now, most people, you just go and click on OK. But since you are going to apply a wind load, what you do right now is to just click on this place. You can see vertical load and then horizontal loading combination. So you click on this place right now. When you click on this place, you now have to come and check this place. You have to tick this place, wind loading. Once you tick this place, wind loading right now, automatically this software now knows that you want to apply wind load to your structure. So right now, you just click right now on this place called OK. Once you click on this, then click on OK right now. Now, once you click on OK right now, you will see all your load case and your load combination, where you have your G plus Q and all that. In my coming video, I will explain all these loading combination for you. So if you don't want to miss this video when I will explain this for you, I will say you should just click on the subscribe button so you don't miss all these videos. Okay, so right now, once you do all this right now, next thing you do right now is to just click on what? OK. Now, once you click on OK right now, automatically, this software has applied wind load to this structure, as you can see it here. But you will not be able to see it, but for you to see that right now, you now have to now click on wind load, because wind load has used to have a value. So you now click on the wind load right now to now define your wind speeds. So once you click on this place, after you're done with your load case and combination, click on your wind load and story loads. You click on this right now, a dialog box appears, as you can see it here right now. Now, on this dialog box right now, the next thing you do right now is to click on wind load calculator. So once you click on this right now, to show you a dialog box, you will now have to understand the dialog box very, very well, as you can see it here. Where the first thing you see is your parameters, and under parameters you're having your basic wind speed, and you can see, and which is measured in meter per seconds. So this is the speed of the wind hitting this structure on all angles, as you can see there. So right now, the first thing you do right now is to define your wind speed. How do you get your wind speed? Wind speed is always gotten from you have to meet your weather scientist around the place where you are trying to build the structure. I would advise that if you don't know any weather scientists around the place you're designing for this structure, I would say you should go to Google. Google always upload wind speed of every location. So you just have to type the location, ask Google what is the wind speed of, let me say, if you're designing this building for, let me say, Lagos or Abuja, you just say, what is the highest wind speed that has ever occurred in Lagos or in Abuja, or let me say wind speed that ever occurred in New York or in US or Jamaica, and Google will give you the highest wind speed that have ever occurred in Jamaica or in Nigeria or in Lagos or any part of the state or country. And also you can also ask Google to show you the current wind speed as at yesterday or some weeks before you are trying to design your structure. Google will give you a value. So you will now have to now I always advise for you to take the highest wind speed that have ever occurred on that area, even if it is in the, let me say, in the 90s or in the 80s, and that is the highest wind speed that ever occurred. So you just use that because that tells you that that is the highest wind speed that have occurred in that area. And also, like I was in a building design for a client in Jamaica, and I tried to research to find any weather scientist in Jamaica, but I couldn't find. So I just went to Google and checked what is the highest wind speed that ever occurred in Jamaica. And Google gave me the highest wind speed that ever occurred in Jamaica, which is 75 meters per second. And that was in the 1970s. And that was when everywhere was plain. There was no much building. All they have are just trees and vegetations. So I use that wind speed. But currently right now in Jamaica, you can see that they have most total buildings, which can prevent any wind wind speed coming to hit your structure, because there are already some, let me say, existing wind speed on that area. So this wind speed right now, it should not be an issue for you. If you don't have any weather scientists around you or they can contact, I would say you should just go to Google, and then you know that Google is the highest search engine in the world. So go to Google and research. You will see most people that have already uploaded some of their projects online, and also you also see Google weather scientists, which they have also done research on that area. So you can just pick the highest wind speed on that area and impute for this for your structure. But if you have someone that can calculate the wind speed for you, I would say that is the best also. But whichever case, the two is still okay. So right now you just have to impute your wind speed just now. In this case, for this building, because this is a live project which we are designing for this case, the wind speed of this structure is 25 meter per second, 25.75 meter per second for the wind speed of this area for this case of this building. And also right now, the next thing to do right now is to also impute your minimum wind pressure. This simply means the least wind pressure that can happen in that area. If you also do the same thing to ask Google will also show you the lowest wind pressure that have occurred in that particular area which you're about to build your structure or the structure. So in my own case, the lowest wind speed that have occurred or wind pressure that have occurred in that area is 0.55. Okay, right now on this place right now, they call it primary wind angle. I would say you should not put any value here on this angle, because wind does not come from any angle. Wind comes from different angles that you cannot just define. So because you cannot define the angle at which wind is coming from, I would say you should just leave this place as 0 as default. Don't put any angle, don't put any value on this place, because wind does not have an angle at which it goes or blows. Okay, so right now on this place right now you can see terrain and surrounding. On this place right now, terrain and surrounding. But let me just explain this for you again with using this diagram right here. Now, this diagram right now, this is just a screenshot which I did. Now, on this diagram right now, you can see that we used our wind speed just here to be 25.75. So what I mean is that, what I simply mean is that, let me say that wind speed of 25 right now is coming this way right now to hit on this structure. Let me say a wind is coming this way to hit on this structure, as you can see it here. Let me say this is the wind direction coming to hit on this structure just now. I can see it there. So the speed of the wind is 25.7, as you can see it here, 25.75 meter per second. So that is the wind of this wind. That is the speed of this wind coming to hit this structure, as you can see there. So the next thing right now to do right now is to now define the lowest wind speed that can occur in that area, and we used 0.55, which we have already defined. And then we say that wind comes from different angle, because you don't know the angle that your wind is coming from. Wind comes from this angle and from this angle and from all other angles, as you can see there. So wind comes from different angle that you cannot define. So I would say you should just leave that wind angle as 0, as you can see it here. Leave it as 0. Next thing that you can do right now, the next thing to do is to impute your terrain and surrounding parameters. Now, on this terrain and surrounding parameters, you will see some values here: HO in meters, XO in meters, and delta X in meter also, and then distance to sill mean level. Now I will explain this to you right now in details. Now on these places right now, you can, if you look at this diagram right now, you can see also they are showing you what this means. But I will use a live project, as you can see it here, to explain what this means for you right now. So I'll just first of all undo all this wind I have already drawn right now and choose another color to draw this wind. Let me use blue, because winds are always shown by blue. Let me use blue to draw the wind, that the wind is coming this way. Let me use something on this shot to draw my wind, as you can see it here. Okay, so right now, what this is telling you right now, this wind speed right now, this place right now, which is the terrain and surrounding HO. This HO simply means, if you can see, if you read this, you see that this is the average level of rooftop of the building, or height, or permanent obstruction upwind on the site. Now this looks like a grammar to you, but let me explain this right now to you in details, what this really means right now. This HO, which is the average height rooftop. So on this structure right now, on this structure, if your wind is coming, let me undo this again. If our wind right now is coming on this direction, let me say our wind is coming on this direction right now. This is our wind coming on this direction to hit this structure. This is our wind coming to hit this structure. This what this software Prota right now is asking you about this HO is what is the average level of rooftop of the building around the structure. Now, if you, let me say this is a site, let me just do another color again. Let me say this is a site that this is a land which we want to build this structure right now. And within this land, within this vicinity, or within this site, there are other existing buildings. Let me use a color of blue, or let me use a color of yellow. Okay, yellow, yeah. Now, there are other existing buildings which they have already built around this area which you are about to build your building. Now, this Prota Structure is asking you, let me say this is the building right now. This is the building. Let me ask, this is the building. This is an already existing building right now. Now, this software is asking you what is the height of this building right now, because the software knows that if the height of this building is very tall, as you can see it here, if it is very tall like this, when this wind blows right now, it will not come directly on your structure. It will have to, this structure already existing, or this obstacle, it can be a tree or anything. We first of all have to break the wind speed first we first of all have to break this wind speed of 25.75 meter per second. And now once it now breaks it, because it will hit on this structure, then what happens is that once it hits on this structure right now, it will now go upward like this right now. Some will now have to divert. So it will not divert before it will now begin to hit your structure. So first of all, this obstacle or this building or this tree has stopped a bit, has stopped at least some of the wind speed percentage from hitting your structure directly. So if let me say what was coming to hit this structure was 25, or let me say 100% of the wind speed, but with this obstacle found on this place, let me say what now diverted into your building to hit your structure is just 25%. So with that right now, that wind speed of 25.75 meter per second, as you can see it here, which was coming to hit your structure, as you can see it here, have now reduced because the wind found some obstructions like trees, like other tall buildings around your building area. So the wind now have to what the wind did was to hit, first of all, hit that obstacle first, then now have to divert into your own structure, which will give less effect to your structure. So in this case right now, in this area where we are trying to build this building, we have only the maximum story building we have here is just 3-story building. So that 3-story building stops around this area. That 3-story building stops around this area. As you can see it here, it stops around this area because this is already a 4-story building. So 3-story building stops around this area. So the highest height on this angle, on this side of the site where I'm trying to build this structure is just 3-story building. And also, if you look, when we check on the other side also, we also have another story again. We have another 5-story building on this other side. So right now, the height of 3-story building is around 10 to 11 meters high. And also, since we have a 5-story building here, which is around 15 meters high to 16 meters high. So also on this area also, we also have a tree, a very tall tree, which is about 5-story building to 6-story building. So that tall tree is not only one. We have more like up to 5 of that trees surrounding the site which we are about to build this structure. So with these features found, which we have 5-story here, and also we also have a 3-story here, and then we have 3 tall up to the height of 6 to 5 story. So with that right now, if we check the height of 5-story building, which is let me say that the story height is 33 meters, so times 5 or 6, that's giving us 18 meters high. So we used a height of 15 meters as the height of this obstruction found before our building. So we use here as 15 meters. Now on this place right now, which is data x right now, you can see it here. X simply means it's telling you XO or X0 is telling you what is the distance. Let me use another color to explain that. It's telling you what is the distance of this obstruction or this building. What is the distance from this tree or this building to where your structure is to be found. So if my structure is to be found here, let me just undo. So this my structure of 8-story building is found directly at this place. So right now they want to know what is the distance between this obstruction, this tree or building to my building which I'm trying to build. So the reason why they're asking you this right now is because we know that when this wind hits this structure right now, as you can see it here, when it hits this structure, it will tend to what? When it hits, it will tend to what? Divert. Now on this diversion right now, it will not just go straight. They will, before it gets to this building, if this distance is very long, before it gets to this building, some of the effect of the wind must have dropped, as you can see it here, must have dropped, and the wind speed must have reduced drastically before it will not hit your building. So if this distance is very long, if the distance of the obstruction before to your building is very long, that means when the wind hit that obstruction or that tree or that building, it will not divert, which will just give small effect to your building. So they are asking you all these things to know how they will now design this structure, because this program has already been designed, has already been programmed with all the factors and formulas that are used for wind speed calculation. In my coming video, I'll be showing you a manual calculation of this wind speed, and I'll show you, and also you will see how this wind speed behave on structures. So if you have not yet subscribed to my channel Ekidel, I'll say just click on the subscribe button so you don't miss my coming video when I'll be explaining this. Okay, so right now, in this case right now, in our own case, the distance of this building is of this obstruction, this tree or this building to our structure is 20 meters. 20 meters. So right now, I'll just go right now on this place where we have and impute this place right now on this distance 20 meters right now, which says that the distance of this obstruction to our building or this tree or building found around the area or the terrain before we can build our building is 20 meters. So I put that value there. Now on this data x right now, you can see it there. Data x simply means site altitude relative to mean sea level. Now it simply means what is the height of the land if you measure the nearest sea around the area. So in this place right now, it gets people always confusing because let me say a sea is found, let me say 1,000 kilometers or 5,000 kilometers away from your building. It is not what you can start measuring that distance. So, and also we know that sea is a very deep, it's very deep. That some of the deeps are more than 500 meters high, deep, and so I would say you should just leave this place as default because you cannot directly know these values of mean sea level. But if you have a weather scientist, they will give you all these values. But in the case where you don't have, I would advise you just leave this place as default as 100, as you can see it here. And also distance of sea upwind, I would advise you leave this place also as 100. Now, in this place right now, as you can see it here, where they have site type. Now, this site type right now, you can see if you click on this tab, you will see site type. You can see a town and country. Now, I'll explain to you what this really means, town and country. Now, if I come to this image right now on this place, let me just undo all these things we have drawn already, since I already explained to you all what this thing means. Now, if you come to this place right now, what that town, this town right here, this town here, what this town and country simply means, what this software is telling you about town and country. When this software Prota Structure say town, what they simply mean is that, let me assume that you are trying to build this structure in New York. We know that New York is a very developed city, that it is hard for you to find any bushy environment in New York because almost everywhere is developed. At least 90% of New York is developed, you have buildings, tall buildings around the area. So this structure is trying to get more let me say, more information from you, because if this building is to be sited in New York or in Lagos, let me say in Lekki, in Lagos, Nigeria, you know that Lekki in Lagos, Nigeria is almost developed, that it is hard for you to see bushy environment in that area. So because of that, there are tall buildings in that area that can stop the wind effect from hitting your building that you're about to build. Now, if you choose town, you're indirectly saying, if you go now and choose this town, you are saying that this structure that we are designing for is to be built in a city like New York, or let me say Malaysia, where there is already where you have a large development, or South Africa, where you also have a large development, which is Johannesburg. Okay, but if you choose country, just like the name countryside or countryside music, it means that you are trying to go into the bushy area, like farmland area, and know what is found in that area is always trees, vegetations, and all that. So in that area, the wind effect of that area will be too much. So if you're trying to build this building right now in the countryside, what I'm trying to say is that you have tall trees on that area, bushy vegetations on that area. So this software right now, we know that on that particular place being countryside, since it is a bushy area, the wind effect of that area will be much, because since you have trees on that area, when wind blows on the trees right now, it will stir up that effect of the wind. You can see that. So right now, so if you choose town, you're saying that this building is to be built on a developed city, and if you choose country, you're saying that this building is to be sited or built in a rural area like villages, or closer to bushy area. So in this case right now, this building is to be built in a town, and the place where this building in this case is to be built is in Lekki, Lagos, Nigeria. So that place is already developed, and there are tall buildings up to 20-story building, 25-story building, 10-story building on that area. And my own and this building is just 8-story building. So you can imagine that we already have other tall buildings of 25 stories and all that around the vicinities. So that's already okay for the wind speed to be broken down before it will not hit my own structure. Okay, so right now, when you come to this place right now, you can see structure property. Now, on this place right now, structure properties right now, you can see here, include dynamic factor. I would say you should leave here as checked, don't uncheck it. Now, building type right now, you can see it here. If you click on you can see here, this is at default category 5. But if you click on this place right now, you can see category 5, you can see that the first thing right there is weathered steel unclad frame building. But if you look at the building which we are trying to design, this is a full concrete building having concrete walls, as you can see here, elevator wall all around. Around this area, as you can see it here. So this is a full framed concrete building. So if you go again right now, at this place, you will see that we are not designing for a weathered steel unclad frame, so we will not check this. If you go again to the next, you can see bolted steel and reinforced concrete unclad frame. So this is not what we're designing for. You go again and say portal frame. No, we are not designing for a portal frame. You go again right now and say frame building with structural walls around lifts and staircase only. No, we don't have only structural walls around the lift area or staircase. We have structural walls, or we have load-bearing walls around the whole buildings, and also this is a full framed building. Okay, so that's not what you're designing for. So, but if you go this right now, this last option right now, you can see that frame buildings with structural walls around lifts and stair with additional masonry subdivision walls. Yes, this is what our building case or category is, because if you look at this place, there'll be walls or cladding all around these areas where you have openings. So this building is not just framed and like an open place. It is a frame building, but also at the same time, we will also put a load-bearing wall or walls all around our building. So this now defines that the category of this building is this last one, which is the frame building with structural walls around lifts and staircase with additional masonry subdivision walls. So we now click on this, check this, and then click on what? Okay. Now, so once you do that right now, let's just minimize this right now. Once you do that right now, we can now go right now to this place and then click on what? Apply. Once you click on this place, apply, automatically this software, Prota Structure, applies this wind speed of 25.75 meter per second into onto our building. So right now, apply right now and then click on what? Okay. So right now, this building right now is being affected by a wind speed of 25.75 meter per second. So right now, this is what the wind speed, this is what the wind load on this building is saying. Okay, so again, right now, once you apply this wind load, next thing to do right now is to click on this place called analysis right now, and then click on this place called building analysis right now. Okay, so first thing, you have to go and click on this project parameter, because since we have applied wind speed or wind load onto our structure, we will now have to go and define the wind load code, because every loading has his own design code. So we will just click on this place right now. We are using British Code of Practice BS code to design for this structure. So click on this place right now and now choose the BS code, which is for wind design, and the BS code of that is BS 6399 part 2 1997, as you can see there. So click on this code right now. If you are in other countries, you can also choose other countries like Singapore. You can choose EM Singapore, which is called Eurocode Singapore, Eurocode Poland, and other countries. But in this case, we want to use British Code of Practice, which is used in UK and most part of Africa, like Nigeria, Ghana, and most other countries. Kenya, they also use UK. So now click on what? Click on pick, and then click on what? Okay. So with this now, you have successfully applied wind load to this structure. You can now click on what? Okay. Now, also in my next video right now, we will be performing a full design for this structure, because we have already applied our load case and we have also applied our wind load to this structure. So what is left right now is just to perform our design, which we will now use this software to design this structure perfectly on this software. And also after our design, we will now move to first of all design our pipe foundation, which, because this building will be designed for a pipe foundation, where I'll show you in details how to design a pipe foundation, also a pipe cap right here in Prota Structure. And then we will now move also to go and detail the pipe foundation, the pipe cap, where I'll also show you how to detail a pipe cap. Now, if you have not subscribed to my channel, I will plead that you should click on the subscribe button and subscribe to my channel Ekidel, so that you don't miss any part of these videos, because I will be posting it in due time, one after the other. And also, I will say that if you have any comment regarding what I have said about wind load, and maybe you have some confusion about what I have said, I will say that you should just drop the comment down below. I will reply you immediately once you comment that, and I will reply you and answer your question. And also, I will plead that you should click on the share button, share this video, and share my channel, and also recommend my channel to your friends and also colleagues to also come and subscribe, so that they will also know how to use this software and also learn how to design building structures and other concrete structures right here using Prota Structure software. In my next coming video, I'll be using Prota Structure 2022, because I just bought the software 2022 version, which I'll be using in my next video. Okay, so right now we have come to an end on how to apply wind load to this 8-story office building complex, as you can see it right here. And if you don't know how to model this structure, I'll say you should check on my previous videos. We have done a lot of video on how to model building right here in Prota Structure. So I'll say you should click on my previous video. We have also done videos on steel designs also. Okay, so right now we have come to an end of this video, on which is to apply wind load to this structure. So we will be moving right now, next video, to design this structure perfectly right here in Prota Structure, which will also check the members which are okay, and then any member which is not okay, we will now have to increase the size of the member, and then make sure that this building is perfectly designed. Then before we can now move to our structural drawing and also structural detailing stage in Prota Structure. Like I said again, let me remind you again, if you have not still subscribed to my channel Ekidel, I will say you should click on my subscribe button so that you don't miss this coming video, and I will also say you should turn on the video notification so that you don't miss my videos when I will upload these videos. Okay, so thank you, and thank you for staying with me to the end of this video, and God bless you.